What's going on, everyone? My name is Johnny Bandon, and I'm your CCNA instructor for this CCNA video series. And in this video, we're going to go over DNS, which is a very important service that we need for our enterprises to work, for us as humans to communicate on the internet, to go to web pages, to reach domains. We need DNS. Now, the CCNA exam traditionally has been for network administrators or people trying to get into networking. And traditionally, which again, we're not in a traditional network anymore, DNS was kind of left up to the services or server guys, where the main thing we're worried about is making sure the DNS packets and requests came across our network smooth. Now, the CCNA exam, or Cisco, does go over DNS, which when I first saw it, I thought like, okay, weird, because as my roles as an network engineer, I haven't had to deal with DNS too much, except for maybe one or two commands on the command line for routers to actually be able to be reachable via hostname. So, or fully qualified domain name. So I get it. But with that being said, I've had students tell me that there was quite a bit of DNS on the exam, going over DNS records and just getting more in depth, I guess, into DNS than just the traditional commands that an administrator may execute on the CLI. So if you think it's a little overkill, we're getting into DNS, it's really not for the way the network is going. And as network engineers, we transition into a more encompassing role on our enterprises, right? We need to know services like DNS like we would know a service like DHCP. So with that being said, let's go ahead and jump right into it. So on the agenda today, we're going to just do a quick DNS overview, why we need DNS, and then we're going to get into the DNS operation, what goes into that DNS request as it comes from a user and makes its way throughout the whole hierarchy. And then we're going to go over DNS records, a very important section. These are going to be the actual text or strings, the actual records that make up DNS, and how we actually communicate to websites is through these records, right, that are hosted by a DNS server. And then we're going to jump into the CLI. So we're going to go over DNS commands that you can execute on a Cisco iOS and why and when you'd use those commands. And then, of course, I just kind of described DNS for network engineers, right? When do network engineers care about DNS and why is it necessary? And there is a few reasons, and mainly the reason in this series is because it's going to be on the CCNA exam. So we need to know about DNS. So with that being said, let's go ahead and get started. So DNS overview. So first off, DNS stands for the domain name system. And what this does is it allows a unique domain name to be mapped to an IP address. So what do we mean by that? So computers, technology, anything that sits on our network, how do they communicate? Well, they're machines. They communicate with numbers. Meaning that the IP address of this PC, whether it's 1.1.1.2, that's all it needs to know about to communicate to this server, in this case a DNS server, which could sit at 10.1.1.3. Now, what if this computer needs to communicate to google.com? Well, that google.com, that search engine, sits on a server somewhere, well, probably thousands of servers, right, that host all that compute resource. Does the computer know google.com? No. Me and you, humans, the way we interact with machines is through our own language, which in my case is English, right? Written alphabetical language. I know google.com. But this computer, without the help of any other service or technology, has no idea what that means. And when you type in google.com into your web address or your URL, on the back end, the only reason or way that computer knows about or where to reach google.com is because it sent the DNS request for the IP address, the numbers, the way that computer communicates. So that is DNS in a nutshell, right? A way for us to resolve a domain name, which is google.com, to an IP address so that human and machine can interact and we can explore the internet using our language. So DNS is going to be needed in all networks because we're not memorizing IP addresses, right, guys? So, for instance, my website, trepatech.com. If I just know the IP address of that website, I can just type that IP address into the URL. But for every website and every service I'm using, I'm not going to memorize the IP addressing. That's DNS. That does it for us. So we can just memorize the names. And then DNS is hierarchical, meaning there's multiple levels to a DNS architecture. And we're going to get into that with the root servers, top level domain servers, and then we have name servers. So, and then resolvers, then we have local cache and our systems. So there is an architecture and it's hierarchical in nature, meaning it takes a top-down approach on who's more authoritative. And we're going to get into that as well. So DNS operation, right? DNS exists to resolve domain names like trepatech.com to an IP address that your computer knows where to send the URL request for trepatech.com. And like I just described in the last slide, I know I get ahead of my slides. There's levels to this stuff, guys. There's levels to it. So for resolving domain names to an IP, it ain't just as simple as, boom, one DNS server that holds all 6 billion IP addresses and what they resolve to in the world, right? So there's levels to it. On an enterprise, you may have your own local domain servers, which could be resolvers that have information about most websites, but when you have a request that's unique that they haven't seen before, it's going to have to reach out to these guys over here, the TLDs, name servers, and root servers for a domain. And I keep using that word domain, and let me just describe it to you. So a domain is this right here, a .com domain, right? That's a top level domain, I guess I should say. Meaning there is a bunch of other subsets to this domain. So what else is there? .net, .gov, .mil. These are all top level domains. So if you belong to the .com domain, that means you probably sit in a .com top level domain, and there's name servers resolving you being now your unique name into that domain. Okay, so people like to throw that word domain around a lot, and it can mean a lot of different things to different people. So we kind of just try to get the exact description of what a domain is, and a TLD is going to be these guys right here. Now, in your own enterprise, you may say, well, okay, let's say I work at Silicon Valley Bank. What's my Silicon Valley Bank domain? Because when I log in, it says I'm logging into svb.com or I'm logging into sv.b. Essentially, your enterprises also have domains as well. So those domains are going to also belong to a top level domain at some way, right? And because those local DNS servers may sit in our enterprise, and maybe there are resolvers or acting as authoritative DNS servers, they're going to know when to reach outside of its own little slice of that domain to reach services and websites and domains outside of itself. Okay, so let's go over the hierarchy. So the life of a DNS packet. So what we're going to do here is kind of describe again, the life of a DNS packet. So what happens when our user here, let's call him Bob, needs to go to, let's say, Trepatech. Actually, no, it's a bad example. We want something outside of our domain. Needs to go to youtube.com. So the first thing that's going to happen is locally, we're going to check a cache. So this computer, when it types in youtube.com and sends that URL request off, it's going to know it needs to do a DNS request because it's like, okay, I need to know the IP address of youtube.com. So the first thing it's going to check is its local cache. And in Windows, I believe that's called the host file. So every computer is going to have a host file. And in that host file, it's literally just a text document that may already have some mappings locally stored so that you don't need to reach out beyond just yourself. That DNS request can stay local to your system. So if I try to go look at my computer, So where is host file stored? On Windows 11, I'm just doing a quick Google search over here. It's going to be in system 32 drivers etc host. So let me bring that up for you so I can show you what that looks like. And yeah, guys, I don't have it memorized where the host file is, so I definitely have to look that up, especially not being a Windows guy. I work with Cisco. Okay, so let's go to system 32. And then it's going to be, it says in drivers, and then etc, and then host. Let's see here. I'm going to open this with Notepad. All right, so this is what a host file looks like. So it looks like we're not even using this host file, and that doesn't mean there can't be some local caching on this machine, but essentially this is what it would look like. And you'll learn about this, but this is essentially an A record right here. This is saying, okay, look, if you want local host name resolution, here's an IP address, and here is the fully qualified domain name that resolves that IP address. So this is actually something you learn about in like cybersecurity too, where someone can affect the host file, and then one computer is doing bad DNS requests, it's taking them to a malicious site, and the user next to them isn't. That's a way you could attack the etc host file. So that's what a host file looks like. Don't save. All right. Now let's say that you can't resolve the name. Again, we're going for youtube.com locally. Then we're going to create a DNS request on port 53. And I believe it's UDP as well. And that's going to go to your local DNS server or your resolver. Now, let's say your local DNS or resolver has never seen a request for this URL before, this domain. It's then going to communicate to the root server. And let me just bring something up real quick. 1 second. So it's going to go to the root server. Right, not that. So I was just bringing up some notes I've written out for you guys. Okay, no worries. Don't have my notes, but that's okay. So it's going to then do that request to a root DNS server. And essentially just going to be a regular DNS request. It's going to say, hey, I don't know how to resolve youtube.com. Can you direct me to the correct IP address? Well, this root server is not going to know about all the little subdomains of the .com domain. What it does know is which top-level domain server hosts the .com domain. So it's going to reply back and say, hey, sorry, I can't resolve that specific request, but I know where to send you, and that top-level domain can then put you in the right direction. And then just some notes on root servers. There are only 13 in the world. The responsibility belongs to this organization called ICANN. And then 12 organizations actually manage them. So we don't need to finish that. So there's only 13 root servers in the whole world and 12 organizations that manage them. So once the root server tells the local DNS, like, hey, here's a list of all the top level domain servers that I know about. Send your request that way. So then this resolver or local DNS is going to reach out to the TLD server and say, hey, I need to know how to resolve youtube.com. And the TLD server is going to say, great, I know where all the DNS, all the name servers sit that can resolve that for you. So it's going to resend a request back, say, cool, go to this name server. This is the name server that hosts youtube.com's information. And let's say this is a Google DNS names or name server. Now it's going to send that request to a name server that's Google host, and that name server is going to say, yes, I know where YouTube sits because I have an A record that tells me that youtube.com's IP address is, let's say, 104.51.64.2. And that's not accurate at all. And so now that name server is going to send that information back. And now this local DNS or resolver is going to store that into its DNS database so that if it gets that request again from one of its users, it automatically knows that, okay, youtube.com sits at 104.51.64.2. So that is the life of a DNS packet, as simple as I can explain it. There's a lot of steps in it when a resolver doesn't know where to send something. But if these are already making connections to name servers and we've already had a lot of traffic on our network, usually DNS requests get resolved right here. All right. So let's go ahead and move on. And again, some of you may know that there's a lot more that goes into DNS sometimes. What about your SSL certs? What about the certificate authority on that DNS server? There's so much. What about DNSSEC? There's so much more that could go into DNS. For a lot of us that have set up DNS servers before, we know it's simple, but it can get confusing. We could go over the whole canonical names, the whole hierarchical nature of the naming in DNS. But again, this is for CCNA. So we're just kind of focused on what makes you pass the exam while also gaining knowledge. So now let's go over DNS records. So DNS servers are all going to have what we call DNS records, which are essentially text instructions stored on the DNS server to fulfill requests. So these DNS records are needed to successfully respond to DNS lookups from users or from other lower level DNS servers reaching out to you. So the first record we're going to go over is an A record. So an A record is going to correlate a host name with an IP address. So this is the very first basic record we need to learn about. So an A record is typically going to be this kind of that top level domain name, not just a .com, but just this name and then the .com after it is going to be an A record, or a quadruple A record, which is just mapping to IPv6. So it's the same thing. So we can see here example.com resolves to this public IP address. And then this TTL is time to live. This is going to be how many times it propagates throughout the DNS architecture globally. So every 600 seconds, we're going to send out information about example.com saying, hey, this is still its public IP address. So that's the time to live, right? Okay, awesome. Moving on, just make sure I described that right. So essentially what I mean by that is if there was a change here, it's going to send out immediately to its neighbors like, hey, there's a change in this, but there's 600 seconds for, like, let's say this DNS server sits in Arizona in America, and there's one all the way, I don't know, what's farthest way in Australia. There's a 600 second time to live on that information reaching, okay? Cool. And then a quadruple A record is the same thing. And then a CNAME record. This is a canonical domain name. So this is going to map an alias name to a true canonical domain name, okay? So what we mean by this is our true domain name is going to be example.com. And we just specified that with this A record here. Well, what if I need to access that domain via the World Wide Web? Or what if I need to access that domain via this FTP service? Well, if I want users to be able to do that, I need to install this CNAME record, which is going to map this little alias here for a service to our true domain name, which we know sits at 130 because of this A record here. So kind of in the order of operations, right? Let's say you're setting up a brand new domain and you got to put it into DNS. First, you're going to do your A record, and then you can start setting up your CNAME records. Okay, and then an SOA record. So this is not necessarily for actual DNS requests. what this is going to do is actually just store administrative information about your domain or your zone. So an SOA record can just show you a lot about things happening in your domain, information that's changed, who your name servers are, who your local DNS servers are. See, here's some name servers here. So an SOA record just stores information about that domain or zone. Doesn't really have anything to do with individual user DNS requests. And then we have a pointer record. So a pointer record is a piece of information that's going to be usually attached to an email message. And the purpose of that pointer record is to verify that the sender matches the IP address it claims to be. So it kind of, if you see it here, it's just like the inverse of an A record. That's how I always think about it. And then an NS record. So a name server record, this is the record that contains the name of the authoritative name servers within a domain or DNS zone. So you can see right here that trepatech.com domain sits at this name servers at Google. And that's actually true. Our name servers are Google because I host our website on the Google Cloud. So those name servers are going to be the ones that host this actual domain, the authoritative name server. All right. So now let's jump into the DNS commands for iOS. So I told you there's really only a few DNS commands that I've used personally in my career and that we need to know about for the exam. So the first command we're going to go over is IP domain lookup. And what this allows us to do is that at privilege mode, if I just type in google.com and hit enter, my router is going to try to resolve that. It's going to try to figure out, okay, google.com is what IP address? And it's going to do that for any command that isn't part of the CLI. So sometimes, right, we turn this off sometimes in lab environments because it can be real annoying if I'm trying to go to conft and I put two F's right here and a T. You're going to get an error message that says, trying to resolve conf with two F's and a T. So it's trying to do a DNS lookup for this right here. So sometimes we turn that off, but essentially IP domain lookup, it works if we have this command here, IP name server. Because out of the box, a Cisco device, just like any other device that sits on a network, doesn't know where to send DNS requests until it gets the IP addresses of its DNS server it's going to be resolving to or sending requests to. So this command is going to specify the DNS servers that this router iOS or this device is going to point to. So when we are doing resolution or DNS lookups, because we put this command in here, IP name server, we're now going to send those DNS requests to Google's DNS servers or whatever DNS server we put there. So that's just essentially setting the DNS servers on a router or switch. And then this command is going to set the domain name on this router. So what this does is it gives this router a FQDN. What does that stand for? A fully qualified domain name. So when I type in this command here, trepatech.com, that means this router is part of that domain for one, but actually it gives it a CNAME lookup, right? Of router.trepatech.com. So if I made like a CNAME record in my local DNS server and I put router.trepatech.com, then that means we could actually really resolve an IP address for this router. And we're going to see how this kind of works when we SSH from our network devices in the lab. And then this command IP host, this is actually going to add an entry to a local host table on the iOS device, kind of just like that host record I showed you in Windows. This is essentially going to do a record that sits at the local database of that iOS. So this router, if it tries to resolve to this long domain name here, or this FQDN, it's not going to reach out to the name servers we configured because it already knows about it because of this command here, IP host. And then we have some show commands. So show host command. This is going to show us pretty much all the DNS information on our iOS device. It's going to show us our name servers. It's going to show us the A records we put in there, or the host records, what kind of Cisco calls it. And then of course we just have a show run a pipe command. And that's just, we could do that show run pipe command for anything we configure and that's sitting on our running config. All right, so that's going to be it for the lecture portion. Before we go, I just want to show you guys some things on like command line, right? How we can also view some DNS stuff. So this command NSLOOKUP is a great way to look at that actual DNS resolution. So you can see here, I'm reaching out to Google's DNS server. And then it shows me right here my public IP address for trepidtech.com. So we did NSLOOKUP youtube.com. We can see all the addresses associated with YouTube. So we got a lot there. Okay, it's probably in a round robin system and probably only for this region. I bet if you do that maybe on the West Coast, it may be different. That's just one way to do like quick DNS lookups on your local system. Just want to show that command because I think DNS, I use NSLOOKUP so much to actually look to see if IP addresses are resolving. That felt disingenuous not to talk about it, even though it's not on the exam objectives. So with that being said, I want to thank you guys for viewing and stay tuned for our DNS lab, where we're just going to go over those simple iOS commands and look at some Wireshark captures. Thank you for viewing.